Hey guys, I thought I would walk through the example that we did about speeding up and slowing down again. I believe most of you were able to get this from class, but just in case you needed a refresher, and for those of you that weren't in class today, this will obviously help you a little bit. So suppose we start with a basic position function. Okay, so s equals f of t, there's our position, and we'll use t cubed minus 6t squared plus 9t. Okay, so this is position. Well, we know velocity, of course, is the derivative of position. So that's going to be our f prime, which in this case would be 3t squared minus 12t plus 9. No big deal. So what I want to talk about now is what happens when we take the derivative of our derivative. What happens when we take the rate of change for velocity? Well, that's going to be our acceleration. Acceleration is the derivative of velocity, the rate of change for velocity. So that's going to be 6t minus 12. No big deal. You literally just take another derivative after you've taken your first. So you have a second derivative here. This, again, this is essentially f double prime of t. All right, that's no big deal. I'm sure you guys won't have too much trouble with that, especially you physics people. But the tricky question comes into play when you're asked, when is the particle speeding up? When is the particle slowing down? Okay, so in order to check that, it's not just simply velocity. The velocity being positive doesn't mean the particle's speeding up. It just means that the particle's moving in the positive direction. So to check speeding up, we have to compare the velocity and the acceleration and look at their actual sign value. So for instance, our velocity is 3t squared minus 4t plus 3, which is 3t minus 3 and t minus 1. So I can check the sign of my velocity with a simple number line, just like we did when we did our little snake graph stuff. So 0 is my starting point, 1 is a breaking point, and 3 is a breaking point. That's when the velocity was 0. So in between 0 and 1, the particle's doing something, then it stops. And between 1 and 3, it's doing something, and then it and then it stops at 3, and then it keeps going. So if I check in between 0 and 1, like a half, we have a positive, negative, negative, which is positive. So I know that my particle is moving to the right between 0 and 1. If I check at t equals 2, I'm positive, negative, positive, which is negative. And then, of course, after 3, everything's positive. So I now know my particle is moving to the right, to the left, to the right. Awesome. That's helpful. Now I look at my acceleration. If I look at my acceleration, I can take out a 6. I get t minus 2 times 6. Now my breaking point for acceleration is actually at 2. So I can check that. So I have 0 and I have 2. Well, if I check 1, of course, I'm positive times negative, which is negative. So I have negative acceleration. And then, of course, when t is greater than 2, any number you want, I'm positive acceleration. So if you look carefully, just carefully here at where the velocity is positive compared to what's happening with the acceleration, you'll notice I have positive velocity and negative acceleration. I have negative velocity and negative acceleration, negative velocity, positive acceleration, and then positive velocity, positive acceleration. That essentially tells you the speeding up and slowing down. You want speeding up? Well, all you have to do is look for where the signs are the same. So right here, speeding up. Your velocity and acceleration are doing the same. They're working together, so to speak. Your velocity is negative, means the particle's moving to the left. The acceleration is negative, means the particle's moving faster to the left. So the best example I could think of, and I said this in class, was think of a car driving. If your velocity is negative, that means your car's in reverse. If your acceleration is negative, that means your car is going in reverse even faster. You are pushing down on the gas pedal in a negative direction. Okay? The other speeding up is probably a little more obvious. Your velocity is positive and your acceleration is positive. So this time your velocity is going forward and your acceleration is pushing it in the same direction that you're traveling. So you literally can have a car speeding up, moving in the positive direction with velocity and acceleration being positive. Now you can be slowing down when these things are acting against each other. So in between here, you have slowing down, which would be when your velocity is positive, your acceleration is negative. So this would be the car moving forward, but literally you take your foot off the gas, and at some point you're eventually going to come to a stop. So your acceleration is negative, but your velocity was positive. Same thing in the middle here. If your velocity is negative, that means the car's going in reverse, but your acceleration is positive, which means it's going in reverse, but slower than it was before. So eventually you'd come to a stop going the other way. And that's how you check for speeding up and slowing down. All you're doing is looking for the sign. So slowing down, velocity, acceleration have opposite sign values. Oh, not sign like trig, sign. There we go. Values. And if you are looking for speeding up, you're looking for your velocity and your acceleration to have the same sign values. And that'll do it. Okay, let me know if you have any questions. I know it's a little tricky here, but if you set up the number line, it sort of gives everything away. And you've already done the number line for velocity. It's just a matter of doing doing an acceleration number line and comparing the two. Okay? Let me know if you have any questions, and I will talk to you guys later.